In order to solve for the missing side of a right triangle, while the other two sides are given to us, we need to use the formula a squared plus b squared is equal to c squared. This is known as the Pythagorean theorem. Don't forget that a and b in a right triangle always are the two legs that form 90-degree angle. These are the two perpendicular legs, two perpendicular sides, and C is always the hypotenuse in a right triangle, also can be located by just looking right across from the 90-degree angle. So labeling everything in this picture, that's your C. A is equal to 4, B is equal to 6. Let's plug into the equation so we can solve for x. So this equation becomes 4 squared plus 6 squared is equal to x squared. Let's simplify the left side. Squaring each of these values, 4 squared is 4 times 4, 16, plus 6 times 6 equal to x squared. 16 plus 36, that's 52, equal to x squared. If you prefer to have the variable on the left side, you can also write this as x squared equal to 52. And we're interested in solving for x. We don't want x squared, so we need square root on both sides of the equation, canceling the power on the left side. X is equal to square root of 52. Always remember at this point to simplify if possible. So let's see if 52 is one of those values that we can keep on going with. We need two factors of 52, one of which is a perfect square. So what those two numbers should be. In general, factors of 52, we could have 2 times 26 or 4 times 13. But remember, when we're simplifying a square root like this, we want to split it up using two factors. One of those has to be a perfect square. So this choice, 4 times 13, is the correct one because 4 is a perfect square value. X equal to square root of 4 times square root of 13. Square root of 4 we know is equal to 2. So the 2 is the number that you see on the outside, and the other value keeps the radical. 2 square root of 13, choice B.